When Einstein first introduced his theory of general relativity, he added a fixed number called the cosmological constant to stabilize the universe. He later said it was his biggest ever blunder, but recently physicists have returned to it and realized that the cosmological constant could very well represent something else: dark energy. Does this mysterious power have to go unchanged, though? This is Unveiled, and today we're answering the extraordinary question: what if the dark energy in the universe increases? Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more fascinating content. Dark energy is one of modern science's biggest mysteries. We know it accounts for 68% of the universe, and that it and dark matter accounts for 95% of everything there is. But apart from that, for something that's so abundant, we're almost astonishingly unsure about it. Dark energy can most easily be thought of as the energy density of empty space. It was only really theorized thanks to another mystery in astronomy: the acceleration of universal expansion. In the minds of many, the most likely explanation for accelerating expansion is the presence of a vast force which pushes the cosmos apart by overcoming the force of gravity, and that's dark energy. We're still in the very early days of trying to make sense of it all, but most scientists currently view the amount of dark energy in the universe as constant and unchanging, that it will always account for 68%. But there are some theories arguing that that might not be the case, that the levels of dark energy could vary over time. If the dark energy content in the universe was to suddenly start increasing, then the first question would be, where is the increase coming from? The universe is a closed system, and the first law of thermodynamics states that energy cannot be created or destroyed. So what gives? On such a large scale, there's no way to know for sure, but it's thought that our universe has the same amount of energy that it did when it first formed right after the Big Bang. Since then, energy may have changed form and location, but it shouldn't just disappear. Equally, it shouldn't just appear either. No extra energy should have ever been added. While universal expansion itself seems to defy this rule, it's actually just more space that's created through it. And the expanding space is filled with gravitational potential energy that's released during the expansion process. Everything is still in balance. But if dark matter is increasing, as some think it could be, then it must be getting the energy from somewhere. There are various theories as to where, some more far off than others. On one end of the spectrum, it could mean that energy from a parallel universe is seeping into our own, or that the seemingly unaccounted for dark energy is actually being stolen from an otherwise unknown realm in the accepted universe. Elsewhere, though, there are some studies to suggest the possibility that dark energy is growing by converting dark matter into itself. And if that's true, could the same process eventually decrease the amount of even visible matter too, turning it into dark energy as well? There's no reason to think so far, but Einstein's famous equation E = mc squared represents the relationship between matter, m, and energy, E, showing that one can be converted into another. The rule takes a rather sinister turn, though, if dark energy is transforming or stealing ordinary matter. If that's the case, then our world could be ever so slowly disappearing, at an unnoticeable but still very real rate. But let's not get ahead of ourselves. Wherever it's coming from, the main thing that we know about dark energy is still that it's responsible for the acceleration in the expansion of the universe. So if it were increasing, so too would the acceleration of expansion. One reason why that would be bad is that it shortens the amount of time that humanity can feasibly travel between the stars. As the universe expands, even at the current rate, galaxies are pushed further and further apart. Look into the sky tonight and you're already witnessing most stars and galaxies slowly recede from Earth, increasing the distance between us and them. It means that while we're reportedly racing to work out how to achieve interstellar travel in the first place, the journey lengths required to do so are going up and up. It was in the late 1920s that scientists came to accept the groundbreaking reality that the universe was expanding. Since then, though, there have been various times when studies have shown the rate of expansion as being faster than had previously been believed, especially in recent years. In terms of today's question, an increase in dark energy would mean that scientists would yet again be astonished when measuring the universe, with expansion accelerating beyond anything we'd ever known before. Confirmation of an increase in dark energy would mean reevaluating our current understanding of fundamental physics, which could lead to a revolution in the field. In our everyday lives, though, we might feel increasingly concerned and isolated. On the one hand, if the dark energy equals disappearing visible matter theory rang true, then there's a disintegrating reality to come to terms with. On the other, just a little less dramatically, we'd know that every other object in the universe was retreating from us at an even faster rate than we'd previously predicted. it would truly seem as though the universe itself was making it as difficult as possible for intelligent life to ever contact any other life forms. Even under today's accepted physical conditions, not only does the speed of light limit travel, but the already vast distances between star systems are continuing to grow even more vast over time. There are already galaxies and planets completely out of our reach forever because they're expanding away from us faster than the speed of light. Add into the conundrum an increase in dark energy then, and we have even more planets and galaxies, which may or may not be literally disappearing as well, moving away from us forever. The universe becomes an even lonelier place, and ultimately, it could find itself destroyed altogether. The Big Rip is one theorized way that our universe will end. As space expands, the largest areas between galaxies noticeably stretch, but in time, smaller and smaller regions will begin to grow away from each other too. Eventually, so the theory proposes, individual star systems will be pulled apart at an accelerating rate, and planets will get dragged away from their home stars. All objects in the universe will find themselves changed forever, becoming more and more detached from anything else. More than that though, as the universe continues to expand, the Big Rip says that even the stars and planets themselves will be gradually pulled apart from the inside, stretched until they tear into increasingly small pieces, and then broken back down into isolated atoms floating in space. If the amount of dark energy present in the universe increases and the Big Rip plays out, then all of that happens at a faster rate, until even atoms of matter are broken down and the universe is left with nothing but a vast expanse of empty space. There is some potential respite, however, even if it's slim, because that empty space with matter reduced to its most fundamental form would theoretically be strikingly similar to something else, what some believe to be the original state of the universe before the Big Bang. A key difference would be that the universe before the Big Bang is thought to have been hot and dense, whereas a post-Big Rip universe would be cold and thin. The physics professor Eric Geweiser, though, finds cause for hope even here. According to Geweiser, it's possible that an increase in dark energy wouldn't finally culminate with the Big Rip, rather that the rip would be one part of something even bigger. The torn-up cosmos could eventually resemble the state of exponential expansion that happened right after the Big Bang. So with dark energy taking over, there could be a reversal at the end of the rip. For Geweiser, it could be that right before the universe stretches itself into nothing, the energy in the space would transition to a hot Big Bang, setting forth a process to recreate the universe. Say this was true, then it'd mean that our universe even as it is could be infinitely old, having constantly expanded, collapsed, and recycled itself via wave-like floods of dark energy. What's important to remember though is that that's just one theory. For most scientists, dark energy is still a universal constant that doesn't increase over time. The idea that it might is a hypothetical, but one with extremely far-reaching consequences, and one that does demand more and more investigation. In early 2018, for example, the scientists Guido Rizzoliti and Elisabetta Lusso found that quasars, huge objects with untold amounts of energy at extremely far distances, appear to have different concentrations of dark energy. In their study, they even concluded that the dark energy must increase with time. It could be that this mysterious substance is Einstein's cosmological constant, but it doesn't necessarily have to be, and if it were to increase in concentration over time, then it could finally explain the origins of everything. And that's what would happen if the dark energy in the universe increased. What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.